Good evening, class. We are looking at section 6.5, average value of a function. Okay. So again, basic integration formulas. Previous sections, the area of the region between two curves, volume, the method of disk, volume by cylindrical shells, applications, section 6.4, work. So let's go to the new section and let's discuss the average of a function. Okay. Well, how do we find the average? Let's have a discussion on that and then we take it from there. If you're interested in averaging anything, you add them up, divide by size. Add them up, divide by size. If you take the average just for n pieces, whatever n might be, remember n can be a small number, it can be a large number, and of course we normally refer to n as a large number. And basically add them up, divide by n, using the fact that delta x is b minus a over n. We are going to replace it accordingly. Delta x is b minus a over n. We want to replace this n, everybody. So what is n? N is b minus a over delta x. Okay, my apologies, delta x over b minus a, I mean, you do the cross product. Okay. So you can interchange n and delta x. Okay, let's do that. So you put the n here, you put the delta x here. Now replace the n with that. We are dividing, everybody, we are dividing by b minus a over delta x. In fact, let me just write it underneath so you see what happens. So instead of n, we can write this. This is a complex fraction, delta x comes up. This is a basic math, okay, class? So we know that. So F average is this summation. So F average is this summation times delta x over b minus a. So F average is 1 over b minus a, this summation. And what is this summation? Let me just, this is f of x sub I. Right, everybody? And what is this? When you take a limit and you let n go to infinity, that it becomes the integral. So recall the limit, okay, of a summation of f of x sub I delta x, as I goes from 1 to n, and as n goes to infinity, this part is equal to this part. So we proved the average of a function is the derivative, the integral of the function from a to b divided by b minus a as we go from a to b. So it looks like this. And what it means in essence, class, okay, let me just go back to this. What it means in essence is the following. If I want the area under the curve, class, if I want this area, I can find a rectangle with the width b minus a with some height such that the area under the curve becomes equal to that. That is the average of the function. So take a look at what happens here. Now, if you look at the area under the curve, which is shaded in green, versus this reddish, pinkish rectangle, they both have the same area. Why is that? I do the cross product here. In this last piece that we have, everybody, this last piece, let me look at this equation, right? What if I do the cross product? What if I multiply both sides by b minus a? I get f average times b minus a is equal to the integral of f of x dx. What is the integral of f of x dx from a to b? Is the area under the curve. What is the left side? The left side is multiplying two pieces. B minus a is the width of this rectangle. F average is the height of this rectangle. And the average happens sometimes in one place, sometimes in more than one place. I hope you see that this point and this point have the same height as the average. Normally, we call them point C, okay? In this case, there are two of them, so C1 and C2. So many times we are interested in finding those locations, okay? It becomes more clear as we look at a couple of examples. So here's the next one. Again, basically we're done. This is the definition. I'm gonna quickly repeat that with this mean value theorem for integral, which says if f is a continuous function on the closed interval of a to b, then there is at least one number c in that interval such that f of c is equal to 1 over b minus a, the integral of a to b f of x dx. And that's the same thing I was just going over. There is somewhere in between. So we went over the f average and how we arrive at it. So there is somewhere in between, because it's a continuous function, that the functional value, which is the height at that point, becomes equal to f average. So the value of f of z is the f of c is the mean in the mean value theorem is the average height of f on a to b. F of c is the same as f average. The area of the rectangle is equal to the total area under the curve. This is going to be an overkill, but let's do this also. It's normally when I go over this concept, okay, I start with the temperature and so forth. So if f is a continuous function in an interval, its average or y average or f average is that formula, and the justification, the average values really did that, okay? We add them up, okay? We just did that in the first place. Let's look at the average temperature for the day. How would you find the average temperature in a day? You can do several readings. For example, you can do every hour and do the reading, or maybe every 30 minutes or every 10 minutes. The fact of the matter is the T average is the sum of the data divided by N, and it becomes better as we do more readings as N increases. So I'm repeating the same as really as the first page, but dealing with the temperature. And so this is the limit of the same thing, okay? As N goes to infinity, that becomes the actual average if you let N go to infinity. So when you're reading at different time intervals, for example, every hour, every 10 minutes, every 30 minutes, if you let n go to infinity, it becomes the exact, if you will, answer. Now, delta t is b minus a over n instead of delta x because we're using t. And so I showed you in the previous page, we can make the change, okay? And we end up with this situation, okay? What happens is that we took the delta t inside. So we kept 1 over b minus a out, and therefore the average becomes the integral, okay? Now you can take this to t dt or take it to f of x dx. It doesn't matter. So it's the repeat of the same thing. Don't worry about that. So let's look at a simple example to make some sense out of this. We are given the function f of x equals x squared. We are interested in finding the average of this function in the interval of 0 to 2, and we know this is the formula, okay? So let's quickly graph it. This is a function everybody is familiar with. Okay, y equals f of x. Okay, y equals f of x equals x squared. So basically, maybe even prior to having that, you really need to know. Let me. So this is the function, but we want to go from 0 to 2. This is not 2 scale, so we are looking at this one as the area under the curve. If we divide it by b minus a, becomes f average. So let's go through the process and evaluate this. So this is 1/2 times 1/3 x cubed from 0 to 2, 2 cubed over 3 minus this one is 0, has no bearing. 2 cubed, of course, is 8. And 8 divided by 2 is 4, so we get 4/3. So this y average is 4/3. That means, class, this distance is 4/3, okay? And as you can see, at some points, it's happening at some point. This is C. By the way, if you're, normally they call it C, they don't have to, you can call it simply X. And all you have to do, set these two equal and find the value of C. That means you find the X coordinate. So if somebody asks you what is the location, that's how you find it, okay? And let's do that, in fact. So the area of the rectangle is equal to the total area under the curve. So I want to look at this example and explain this concept a little bit. Is better if we have it from the scratch, okay? So the very first thing, y equals x cubed, everybody knows, it looks something like that. So we are looking at 0 to 2, everybody. So that's the portion. If I were to, let's see, what color do I want to use? Okay, if I wanted to shade the region, this is the region of interest. So we want to find the average. We are going to take the integral and divide it by b minus a. Okay, this one gives you 1/4 x to the power of 4. So 1/2 times 1/4 x to the power of 4. Plug in 2 to the power of 4 is 16. 16 divided by 4 is 4. This is 4 times 1/2 gives you 2, which means the following, class. Look at the height. This is f average. Now the question is, we want the value of C. That means, where does it occur? Well, you can see it clearly here. We want the x coordinate for that, okay? So all you have to do, say f of x is equal to 2. X becomes cube root of 2. And if you put it back into the original function, it gives you the pair cube root of 2 comma 2. I hope it's clear to everybody. Okay. Let's look at the next one. This is actually a very simple section class. We want to find the average value of this function from 1 to 4. Well, 3x squared minus 2x, this function f of x, roughly here's the graph, and we want to go from 1 to 4. Okay. And so if you plug in 1, you get 1, 1. Okay, so 1. If you plug in 4, 4 squared is 16 times 3, 48, minus 2 times 4, 8 is 40. So if you plug in 1, you get this pair. If you plug in 4, you get this pair. And so we are interested in the area under the curve. Okay, find the average from 1 to 4. In essence, you can find this and divide it by b minus a. So let's go through the process. All right, 1 over 4 minus 1, the integral of 1 to 4, 3x squared minus dx. Okay. Okay. This gives you x cubed minus x squared. So 1 over 4 minus 1. 1 over b minus s is 1/3. Now replace it with 4. Okay. So 4 cubed, which is 64, minus 16, and then replace it with 1, which gives you 1 minus 1 or 0. They two cancel each other. This is 0. You get 64 minus 16 only, and then times 1/3. 64 minus 16, the whole thing goes to 48 class. Okay, so this whole thing changes to 48. So find the average. We are done. We found the average. The average is 16, everybody. Okay, the only thing that, this rectangle didn't work out good. Let me just actually fix it. The rectangle is supposed to be here. Okay, so let me just actually fix it in the following manner. The rectangle is supposed to be at 1. I didn't show it properly, so let me just show you now. Okay, and that's the idea. Okay. Now, understand it happens at this point, and if you want to find this point, you set the function equal to 16, and you can find the x coordinate of that point. Okay, class? There may be two answers, but there's only one in between. Okay. So that's how you find the average. It's pretty straightforward. Let's look at an example of application here to see how that thing works. Rico's speed in miles per hour. So the speed is in miles per hour. T minutes after entering the freeway is given by this function. Okay. From 5 minutes after entering the freeway to 25 minutes, what was Rico's average speed? Class, we use F average. We use F average. And please understand, because it says minutes, it's okay here. But the answer for the speed is miles per hour. So don't mix them up. So this one says freeway is given by this minutes, T minutes after entering the freeway. So let's find 1 over B minus A, 1 over 25 minus 5. Okay. The integral of A to B, 5 to 25, V of T dt. Now, please understand, conceptually, this is extremely simple, but it is tedious. It does take some time to calculate this. Okay. So a question like this, for the integration part, the calculus part is extremely easy. So this becomes 1 over 20, okay, times this becomes 1/4 t, so times this one becomes negative 1 over, so negative 1 over 200 times 1/4, that becomes negative 1 over 800 t to the power of 4. Now you have 3 over 20 and then times 1/3 becomes 1 over 20 t cubed. You have minus 3/8, okay, and then 1/2 t squared, so minus 3 over 16 t squared, and then 60 t. So this part is not too bad. Now evaluation class does take some time because you have to plug in I mean, it's really not too bad. You can use a quick calculator, plug in 25, do the math, plug in 5, do the math. It ends up being a nasty number. And so 68 and 3/4. What are the units? The units of speed class. I know this is in minutes, but units of speed. So the speed is in miles per hour, and the average is taken over the course of so many minutes. So the answer is 68 and 3/4. Now, the next part is asking, okay, how far did Rico travel over that interval? So remember what happens. This is the average speed. I hope you remember D equals RT. The average speed, if you multiply it by time, gives you the distance. Now, how much time? From 5 minutes to 25 minutes, we covered 20 minutes. However, look at the units. This is miles per hour. 20 minutes means 1/3 of an hour. So over the course of 1/3 of an hour, how far did we go? 1/3 times this number. So I hope you realize D equals RT. It is what you're interested in. Okay, everybody. D equals RT. Okay, but you need to know the proper timage. Okay, D equals RT. And of course, you plug in, you do the numbers, it gives you the answer. So the only thing I want to add, I'm showing you an exact answer. Of course, you can use a decimal, maybe 1 or 2 decimals, or however many they ask you to answer this. Okay. Now, let's look at the last question I want to do. Again, an application problem. The temperature in a winter time is given. X is the number of hours between 0 and 24. We want to find the average temperature in Minneapolis during this 24-hour period. Well, we use this F average that we have seen the formula for. So we are going to use that. Where A and B, A is 0 and B is 24. That's all. A is 0 and B is 24. Again, this is sort of nasty, to be honest with you, okay, because it involves decimal and so forth. Conceptually, extremely simple. All you have to do is integrate and plug in. So this is negative 0.012 times 1/4 x to the power of 4. This is plus 0.3.8 times 1/3 x cubed. This is minus 1.99 times 1/2 x squared, and then minus 10.1 x from 0 to 24. We have this one in front. So we have 1/24 in front. We do the integration from 0 to 24. Now you got to plug in 24. And then minus 0. When you plug in 0, clearly everything goes to 0. Do you see that? So just plug in 24. And the reason everything goes to 0 because everything involves x. This is x squared, x cubed, x. And that's a good thing. That makes life easy. So just plug in 24. Again, using a calculator, putting them together. As I mentioned, this is a little bit tedious. And whenever you finish the job, you answer it properly. Anytime you do application, you answer it with what? Units, if units are given. Okay, everybody, if units are given. So degrees Fahrenheit. Degrees Fahrenheit. Okay, everybody. There are a couple more questions that basically repeat the same thing.